Okay. So last time we reminded ourselves about this MUD kind of idea, this multi-user dungeon game. And we're going to use that as we're going to kind of catch up to where we were last semester, and then use that to start looking at object inheritance. We're going to look at multi-threading, several different things along those lines. All right, so we want to kind of identify our, and actually, can I steal from last semester? Nope, that didn't work out. Whatever, we'll just say it's good enough. So kind of designing the department with this this kind of thing in mind, where we have a collection of rooms. Linking those rooms are exits, where an exit is kind of a two-way portal between rooms. All right, and then ultimately putting a player in our room. But then we might want to have other inhabitants. That's where the inheritance stuff is going to start coming in. So let's design our starting point for these objects so we can start creating our initial objects. So we're going to need an object for a room. We're going to need an object for an exit. And then we're going to need an object for a player. Those are the three things that are going to inhabit our world initially. Okay. So we're going to have a room object. We're going to have an exit object. And we're going to have a player object. All right. And we're going to keep these pretty simple initially. So a room will have a name. And it's going to have a collection of exits. All right, we'll talk about some new collection types when we start implementing that. An exit will probably have, I think if we think about what we did last semester, it kind of had two names, right? So you had an exit like this exit right here had an exit to the north, which led to a destination, and an exit to the south, which led to a destination. Now we could do it that way, or we could have separate exits where an exit is always a one-way street. Okay, we can decide which of those makes sense. I think we should just do a room has a collection of exits where an exit is a two-way street, because that's how it is represented in real life. If I'm standing in this room, depending on what our orientation is, I guess based on this, we would be in this room right here. If I took the door from inside this room, I'd be heading to the south through this door. If I'm in the hallway and I took this exit, I'd be heading to the north into this room. So we really need to have two destinations and two names, the name leading to that destination. All right, so we're going to have a destination 1, direction 1. Destination 2, direction 2. Okay, so that's the information that an exit's going to hold. All right. Then a player is going to have a name, and a player probably also knows what their current room is. And with that in mind, a room probably also has a current player, which we will upgrade as we start allowing there to be more than just a player in the room. All right, so this is going to be kind of our initial stab at what are the things that are going to be involved in our MUD. Okay, so let's go and create these objects. I don't think I created one for our MUD yet, right? Oh yeah, we did. Okay, so, oh yeah, this is just our starting for it. So we're going to go ahead and create these objects. So I'm going to create a new file. And we're going to call this guy room.java. We're going to create another file. We'll call this guy exit.java. And another file, player.java. Okay, so for player, this is going to be public class player. And a player, by our design, will have a name, which is probably a string, and we'll have a current room, the room they're currently in. So we'll have a private string name, and we'll have a private room, current room. Those are the two pieces of information, at least for right now, that we're going to keep track of for a player. All right, and let's go ahead and fill out the same fields for our exits and our rooms. Then we'll come back and write our constructors. An exit is going to have a destination one and a direction one. So destination one is an exit leads to a room, and a direction is probably a string. So this is public class exit. And we'll have a private room destination one, a private room destination two, a private string direction one, a private string direction two. So those are the four pieces of information we're going to keep track of for an exit. And notice initially I make everything private, and if we decide it makes sense to loosen the reins a little bit, we will, but we'll keep everything locked down initially. Lastly, our room, it's going to have a name, probably a string. It's going to have a current player, probably a player. And then we're going to talk about this collection thing here. Our room will be public class room. We'll have a private string name. We'll have a private player, current player. And now we need to think about our collection types. Based on last semester, what we used is an array, right? All right, what is, remind me what an array is. What can you tell me about arrays? We already know it's a collection type. It can hold a bunch of stuff, right? What information can you give me? Go ahead. Okay, contiguous memory. What does that mean? Okay, so all the elements in the array are stored right next to each other in memory. What benefit does this give us? So yes, that's the way it works, but why? Why did they make it work that way? Go ahead. Speed. This makes it fast because you can calculate Like if you want to get to bucket 7 of the array, element number 7, you can go to the beginning of the array, whatever the base address is, and then take 7 steps in and go right to the memory address where bucket 7 would live. You can calculate where that lives in memory and immediately go there because you know that everything's sitting right next to each other in memory. So this makes it fast, but it also makes it memory inefficient. And it makes it memory inefficient because when we first create an array, we have to request all the memory that we think we might need right off the bat to hold however many things we're going to hold in the array. All right. With that in mind, our room is going to have a collection of exits. How many exits might we have in our room? Good. Maybe 4, maybe 2. I mean, at this point, we're sticking with the cardinal directions. Could we legitimately have an infinite number of exits until we run out of memory, I guess? You know, we could have an exit up, an exit down, an exit through a portal, you know, whatever it is. We don't know how many exits are going to be in a room. So it would be nice if we had a more flexible collection type. All right, so in Java, so we're going to say something here like this collection type is inflexible, since we need to define it to be its maximum size right off the bat. All right, so now there's a bunch of collection types that already exist in Java. We're only going to introduce one in here because the next course, CSC300, we look at writing linear and nonlinear linked data structures. We write our own collection type. So for example, built into Java, we do have something called a linked list. We have something called a stack, a queue, yada, yada, yada. We're not going to use those in here because we're going to learn how to write them next semester and then we'll use them. But we're going to use kind of a middleman in here called an array list. All right, so let's go open up the documentation here. So here's the array list in Java. So we see it's kind of its lineage here. So like we discussed before, all objects in Java come from at some point in its lineage from the base object class. They all get that toString method as well as those couple of other things. But this object is also something called an abstract collection, whatever that means, but it's some kind of collection thingy, which is an abstract list, which comes from an abstract collection, but this guy specifically is an array list. All right. Now, whenever you see a syntax like that at the end of something, sometimes you'll see a T in there instead of an E, whatever. All right. That is something called generics. I'm just going to introduce it initially. This is the ability for an abstract type initially created to hold generic objects to hold a specific type such that you can add specific values or specific types to the collection. And maybe more importantly, when you get a value from the collection, it comes out as the specific type rather than a generic type. And what we mean by that is if we had a generic array list, So we just create this thing that knows how to hold stuff. Anything that is an object, which all objects are objects, right? Any object we might invent at some point in its lineage is a generic object. So we could create a collection type that knows how to hold anything that's an object. And with that in mind, we could put anything we want in there that is bound by, that is an object type. We could put rooms in there. We could put exits in there. We can put players in there because all of those at some level are objects. But when we go and take our value out, it'll come out as a generic object, even if it's a, let's say it's a room or an exit. Okay, so if I put an exit into an array list built for holding objects, when I take that exit out, it's going to look like an object. It's going to be like in a costume. It's still an exit. You know, upon closer inspection, we can figure out it actually still is an exit. But it's going to come out as an object, and Java is going to think it's only capable of doing things that objects know how to do. It's not going to have the exit abilities until we turn it into, until we typecast it to the type it actually is. So let me show that in here. We go back to our main. So I'll create an array list there. Let me make sure that guy's not in like Java. He is in Java.util. So in order to use array list, I'm going to have to import java.util .ArrayList. A lazy programmer would say, just give me everything that's inside of java.util, java.util.star, all the crap that's in there, give that to me. I don't know, more conscientious programmer would say, only import the classes that we actually need to import. If I'm only going to use array lists, only bring array lists in. It'll make the size of your executable smaller, although realistically modern day compilers would probably go through and figure out what you didn't use and then turn it into an efficient executable anyway. So I would say one of the jobs of a modern day compiler is to make a bad programmer look like a better programmer. They're optimized over and over and over again to take your little mistakes or whatever, you know, the things that you could have done better and make them more efficient. It won't turn erroneous code into working code, but it'll turn unoptimized code into more optimized code, potentially. All right, so I'm going to have my array list here. And I'm going to go ahead and I'm going to create a room R1 is equal to a new room. And we didn't write a constructor, so all of our objects get an empty constructor. Room R2 is equal to new room. And if we look at the abilities of an array list here, so this is the constructor I used. I built an empty array list. And notice it says it has an initial capacity of 10. So the punchline here is even though we're not going to be in charge of making our collection type bigger or smaller, you know, because we said that's a limit of arrays. If we make our own normal plain Jane array, we have to kind of say, give me all the memory I'll ever need right off the bat. And then if I want to store less stuff in there, I just have to keep track of how much stuff that I actually store. Where an array list is actually still built on top of contiguous memory. It just does that heavy lifting for you of maybe destroying memory or optimizing memory or whatever. So an array list initially says, okay, I'm gonna guess that you're gonna hold 10 or less things. And then if you need to hold more stuff than that, I'll kind of expand somehow. As the programmer, we don't need to worry about somehow. We just need to know that this tool lets us keep throwing stuff into it and it just works. Okay. Notice there's also a version of ArrayList where we can give it an initial capacity. If we know we're going to need 100 things, it might be nice for it to go ahead and grab elements of 100. If we only need 4, we say, hey, I only need room for 4 things. But at that point, if we know exactly how many things we're going to store, we might ask the question, why didn't you use a normal array? Doesn't necessarily matter for us here. We're using this tool. All right. So we have a function here called add, which just adds something to the end of this array list. And notice it is not a static method, which means it's an instance method. It's owned by an instance. So we will need an instance of the array class in order to call the add non-static method. Make sense? So even though this is the first time we're seeing ArrayList, the stuff we've learned about how do we identify the types of methods we're looking at and how do we call those different types of methods allow us to read this documentation. So I'll go ahead and say ar.add R1, ar.add R2. So I built my array list to initially hold generic objects because I didn't teach the array list. I didn't say, hey, I'm actually going to store rooms in you. The default version of an array list just says, hey, if you don't tell me anything better, I'm assuming you want to hold objects, which just kind of is the catch-all, right? Everything's an object. So I could put rooms and exits and players. I could just free for all, put whatever I want in here, which sometimes is what you want. Correct? I mean, that could be a handy tool, is now we have a collection type that could just, you know, it's kind of like Santa's bag, right? Just throw all sorts of stuff in it. That might help us. And we'll look at that here in a minute. Okay. So now I'm going to go ahead and print a couple things out. So we're going to print out the value of AR, which we expect to be some kind of memory addressy thingy, right? Why? Because we see this new keyword there. All right. And what kind of memory address thingy do we expect it to be? We expect it to be an array list. We'll do a system.out.println, and we'll go ahead and say R1, which we expect to also be a memory address thingy called R1. And it's of type room. And then we will also go ahead and print out AR, and I said I think it's just get. Yeah, get. You give it the index. And I'll say, give me the value at bucket 0 from AR. And notice here we added R1 to the end of the empty list, which put it at bucket 0. We added R2 to the end of the array list, which put it at bucket 1. So R1 lives at bucket 0 of our array list. So these two lines should be printing out the same thing. And hopefully the recent version of Java doesn't just fix this for us, which is always a risk, but let's see what we get out of this. I expect it to be an object type, the second one. And of course not, it comes out as a room. Let me just see if I can prove this real quick. Actually, we'll call this guy room. Okay, good. So at least proves our point. All right, let me just kind of walk through what I just did. Since I haven't finished writing room yet, I went ahead and changed name to not be private. That way we have access to it outside of here. If we want to be more explicit about it, I'll make it public. If you don't put anything in front of it, it's package level security. So anything in the directory has access, and we're all in the same directory here, so we would have access. So I just loosened the reins on the name variable temporarily so I could prove a point here. So all rooms have a publicly accessible name variable that happens to just currently say empty room because we have not written a constructor yet. We're not done writing our rooms. We're messing around with array lists for a few minutes. So now I created my generic array list. I created a couple of rooms. I went ahead and added those rooms into my generic array list. Now, when I add, even though I put a room in, it was going in as a generic object. So when I get it out, even though when we printed it, it showed us the memory address was actually a room memory address, this guy right here is coming out as a generic object. And objects don't have a field called name. I'm just telling you they don't, but rooms do. So R1 and R2 both do have a field called name here, right? And we know that this guy right here is R1. So that's a room. But when we get it, it's going to come out as a generic object. And then I'm asking that generic object to give us your name. And it's going to say class object. We know we put it in as a room, but it's going to come out as an object. Say class object does not have a variable called name. That makes sense? So we could say, well, we could, since we know it's a room, we can go ahead and we can say, go ahead and typecast that guy to a room. This right here will come out as an object. We happen to know it's a room. So we will put before it in parentheses the type that we want to turn it into. Really, it's the type we want Java to treat this guy. Treat him as a room. Now it will know about the name. So there's our empty room. We knew we created R1 to be a room, and we know that when we put it in, we put a room in there. But by default, when we took it out, it came out as a generic object because of the way we built our array list. Our array list knows how to hold all sorts of things. All right. So this array list, I could say exit E1 is equal to new exit. I can say player P1 is equal to new player. So I'll create a whole bunch of different kinds of things. And we'll say ar.add. I'll just add it in the middle here. We'll say E1. We'll say ar.add P1. So I added a room, then an exit, then another room, then a player. All right. So since I built my array list to hold generic things, this is okay. I'm not sure it's overly helpful, but we've effectively created Santa's bag. Put whatever we want in there, right? So I'm going to write a little loop for int I is equal to 0, I is less than ar dot, I think it's size. So we're going to go back to our documentation here. How do I find out how many things are in an array list? Here's a method right here called size. It returns the number of elements in this list. So I equals 0, I is less than ar dot size. Again, here's the size function, takes no parameters. It's not a static method. Therefore, we need an instance of the class in which this method was defined. We need an instance of ArrayList. AR is an instance of ArrayList, and we're going to use it to call this non-static method. So we're going to go through every element of our array, or every element of our array list. And we're going to go ahead and we're going to ask some questions. Now we know that this guy is going to come out as an object. So I'll go ahead and just create a little variable to hold that guy. So we'll say AR get whatever's at bucket I. Now, just to prove what's going on here, I can say system.out.println. I'll print out O. And we see those are the different types we put in there, right? We loop through every element of our array list. What came out of the bag was a room, an exit, a room, and a player. But we won't be able to call on those guys' functions. So if I, for example, say if O is an instance of room, we'll talk about that here in a second. Go ahead and print out that room's name. So we're going to go through every element of our array list. We'll go ahead and put that element into a object called O, because this guy does come out as an object because I built it to hold generic objects. Then I'm going to ask a question. We have a new Boolean operator here called instance of. Instance of. So this is a Boolean operator that returns true if the left-hand side is an instance of the class on the right-hand side. So for example, R1 instance of room, something like that. It allows us to ask a question about an object. Are you one of these guys? Because right now you look like an object at a glance. All right. But I now have the ability to ask, are you a room? If you're a room, what am I going to try to do? I'm going to say, if you're a room, and only if you're a room. I ignore all the other ones, right? I only have an if statement that detects rooms, and I only try to print something if it's a room. So I'm only in this if statement if O is in fact a room. Okay, we get our same error. It doesn't know about name. Never heard of that guy because O is still of type object. But I'm only inside of this if statement if I actually know that O is a room. So since I know it's a room, I can go ahead and I can say, treat this guy as a room. I think it'll run like that. I don't have to do the extra set of parentheses. Nope, I still do. So you put in parentheses the type you want to cast it to. So we could actually write it like this. Room R is equal to the room version of O, if you like that better. And then I can say R.name. That probably looks a little cleaner. So I'm going to define a variable of type room called R, and I'll store in there the room version of O. And I know I can do that because I'm only in this if statement if O was a room. So now I should be able to say R.name. So for the two rooms we had stored in there, it was able to go ahead and get the name of those two rooms. Go ahead. Yeah, it's public still. Yeah, I haven't changed it. And that the only reason I've done that is for this example. We're talking about array lists for today's class. I only did this to make sure this variable was easily accessible for us to do our little experiments here. All right. And by the way, this is something I do suggest you do when you're programming, especially when you start using another tool. Mess around with the tool for a few minutes in main and make sure you got a good feel for how it works. You know, you buy a new table saw or something like that from Home Depot, you probably don't start using it immediately on your project. Maybe you do it on a couple of test pieces of wood before, so you kind of know what you're doing, unless you're a professional and have used this stuff a zillion times, but you get my point. Go ahead. What are we talking about here? Well, yeah, that's just counting. So if I make that a long, I can still put this in there, but that's kind of, yeah, that's not really related to what we're doing here. But actually, let's look real quick just to finish. So size returns an int. So we know that an array list cannot hold more than the size of an int. So we would never actually need to ever use a long, because getting bucket 5.2 billion would not be a thing for an array list. It can't hold that many things, presumably, because its size is always going to return an int, which has a maximum size of 2.1 billion positive. All right, so if I'm in this if statement and I know that O actually is a room, I'll go ahead and say, oh, I'm going to treat you as a room now. Make sense? Now, if we want to break this, players also have a name. I'll say, hey, if you're a player, so we should only get into this if statement once. We only put one player in there, right? If you're a player, I'm going to go ahead and make you a room, just because. And then I'll try to call your name. So first of all, it yells at us, say, hey, look, O is actually a player. You tried to turn it into a room. That's not allowed. So we have to say, okay, fine. We'll turn it into a player. Now, looking at player, we see that name is still private. So now we have our player called R. We're going to try to get R's name, but it's going to say, yes, it's a player. But, and yes, players have names. But because it's private and we're not currently in the player class, it's hidden from us. We won't be able to access it. So we'll get another error. Private access in player. That make sense? So this instance of Boolean expression allows us to do some different things. So we can say system.out.println a player, something like that. And maybe we have an else if it's a room. We print out a room. Else if it's an exit, we print out an exit. So if we did decide to use an array list to hold a whole bunch of different kinds of stuff, and by the way, this is going to be helpful for us once we start having other kinds of inhabitants in our mud, not just players, but also maybe rats and other kinds of monsters and things like that. Might be handy for us to say, hey, are you a player or are you a monster? Because maybe those guys don't behave the same. All right. So we can ask a question as we're taking a value out because it's coming out as a generic object. And we can say, what kind of object were you? And now we should get room twice and player and exit once. Right, so makes sense how the instance of Boolean operator works. It allows us to ask whether an object is of a certain kind of type. Now I mentioned this thing called generics. Generics is the idea of taking a class that was implemented using generics, and we can tell that from documentation whenever we see this little thing at the end. That means you can build this guy to hold specific types. And if you build it to hold specific types, I'm just going to go down here to get, because we've used that a couple times. Know thy alphabet. All right, so notice that get here returns whatever kind of value this guy was built in terms. By default, it'll return object because that's its best guess. But get will return the kind of value that you built the array list with. So if I go back in here and I say, you know what? I actually want to create an array list of rooms. That's what I want to hold in here, is a collection of rooms. That would be the syntax for it. Okay, now keep in mind, I'm putting a couple of things in here that are not rooms. So let's see how Java feels about that. Exit can't be converted to a room. Player cannot be converted to a room. Notice if we look at the add function, the add function takes in whatever type it was built with. If I didn't build it with a specific type, it's expecting anything that's an object, which gave us all that flexibility to put whatever we wanted into Santa's bag, right? But since we're now building this guy with a specific type, I'm saying this array list knows how to hold rooms. I can't put an exit in there. I can't put a player in there. He only holds things that are rooms or things that come from rooms. When we talk about writing our own examples of inheritance, we'll see that. You know, maybe we create a class called a gymnasium, which inherits from room. So then I could store gymnasiums in here since they are rooms. All right, so this allows us to create a specific object type using generics. And I guess this code would still work. We'll just do a. So now when I say AR.getBucket0, that guy will come out as a room. So he will have a name. I don't have to cast him to anything. So that's kind of the advantage of generics. Most of the time when we create collections, we're creating collections to hold a bunch of similar values. Make sense? Okay, so with that in mind, if I built it in terms of room, when I say AR.getBucketI, it's going to come out as a room. And rooms have names. So I won't have to do any sort of typecasting or anything like that. Go ahead. Correct. I would say it's not overly common to use instance of, other than if you, and it's not just for examples of like the Santa's bag type thing where you just want to put everything under the sun in there. But let's say you want to have a collection of cars, and maybe within your collection of cars you have you know, trucks, or maybe you have a collection of automobiles, and inside there you have cars and you have trucks. You might use instance of to say, hey, if this automobile is a car, do one thing. Otherwise, do something else. So that would be a legitimate example of using instance of under normal circumstances where you're creating a collection of automobiles, which makes sense. But automobiles come in a couple of different flavors. So you might want to know what kind of flavor this guy was and maybe make different decisions based on that. But I would say the most common use of an array list is going to be very similar to what we did with arrays. And these guys hold a collection of like type values. So typically when we're saying I want an array, it's going to be an array of ints or an array of chars or an array of rooms. We're holding a collection of the same kind of stuff. Make sense? So with that in mind, you're not necessarily going to use instance of all that often, but it is one of those tools that's pretty handy. Okay, for those of you who've done some programming before, done some object-oriented stuff, and you kind of know enough to be dangerous or whatever, if you didn't know about instance of, it's kind of a frustrating thing to not know what kind of value something is. All right, so that makes sense. So that means in our room, I'll go ahead and make this guy private again. Remember our design for room said we should have a collection of exits. So that means in room, we're going to import java.util.ArrayList. And I'll go ahead and say private array list of exit. If we call this guy the exits, something like that. So now we know how to hold a collection of exits within a room. Make sense? All right. Questions, comments, concerns, bribes? All right, I'll see everybody on Friday. Friday we'll clean this up, and then over the weekend, you'll be putting together our collection of basically building our map. So if you wanted to jump ahead and get that out of the way now, you can finish these objects and do that, but I won't assign it as a homework assignment. Go ahead. They're unrelated. So this is in the room class. So the scope of the exits lives and dies in here. Out here in Maine, all the stuff I did before still stands. They're not conflicting with each other because they live in two completely different scopes. All right, I'll save this and I'll go ahead and put the link up to this code on Slack in case you wanted to take a peek at it. Yep, have a good one.